So we're going to start our notes for 11.5 today by doing a little investigation. We're going to be looking at the area of similar figures. Whoops, didn't want that. The area of similar figures. And what I want you guys to do is I want you to just kind of eyeball it. I know you don't have rulers or anything at your desk, but go ahead and just double the dimensions of this rectangle. So you can just kind of eyeball what this would look like. Just draw it over here, double the dimensions, and draw a new rectangle off to the side. So when you do that, what happens to, let's say, first of all, the perimeter? What happens to the perimeter of that new rectangle? It's doubled. But what happens to the area? Is the area just double the area? No. How many times more is that area than the original figure? 4. Yeah, because if you draw those in, do you see that if it gets twice as long and twice as tall, it actually is not just twice the area, it would be 4 times the area. Okay, and this will be true that if you double the area, it's not just, doubling the lengths of the sides, it would not be just doubling the area, it'd be multiplying it by 4. So the area here is 4 times the original. And this is really important to see. In this chapter, we'll also extend this into next chapter when we're doing like 3D shapes, that you know that just by changing like one length doesn't just double that, it would have some other effect. Let me go ahead and scroll down. So looking at this example here, it's not saying that it's half the size. It's just saying it's some sort of ratio. We have some sort of similarity here. If I'm looking at this one, the perimeter of figure B, if I'm adding those up, well, that would be 5K plus 9K plus 5K plus 9K. What would the perimeter of that figure be? Right, 28K. And then what's the perimeter of figure A? 28. So then this ratio is whatever K is. Okay, whatever that scale factor is. It might be half the size, it might be 3/4 the size, it might be 10 times the size. That ratio is the same as that multiplier here. But when I find the area of figure B, so if I multiply 5K times 9K, what is that? 45K squared. And if I find the area of figure A, that's just 45. So the ratio of these areas is not just K, the same thing as that scale factor. It's whatever K squared is. Like the last example where we doubled it, it ended up being 4 times. It's not just twice as big. It's whatever that multiplier is squared. So it just happens to be the same thing. 2 times 2 is 4. So here we go. If 2 polygons are similar, then their areas are proportional to the square of the scale factor between them. So somebody make up a scale factor quick. 3 to 2. So if the scale factor is 3 to 2 for the sides, the scale factor for the areas would be whatever 3 to 2 squared is. So that's going to be 9 to 4. So the ratio of the areas would be 9 to 4 if the ratio of the sides is 3 to 2. Somebody make up another scale factor quick. 6 to 1. So if the scale factor is 6 to 1, then the ratio of the areas would be whatever 6 to 1 squared is. And you could just write this as 6 if you wanted to, or 6 to 1, doesn't matter. This right here would be the same thing as 36 to 1, or you could just write it's like going to be 36 times the area. Okay, so we're going to show you this with some examples now, and hopefully if it's not clear yet, it becomes clear then. So for this one here, it says, for each pair of similar figures, find the area of the figure on the right. So like for this green one, what's the area of that compared to this blue one? So what I would do first is I would find the ratio of the sides. So the ratio of the sides is 8 to 5. That is not going to go into your proportion. You're going to put the ratio of the areas into your proportion. So what's the ratio of the areas for this? How can I find the ratio of the areas if the ratio of the sides is 8 to 5? I would square them each, right? So when I square each of those, the ratio of the areas is going to be 64 to 25. So if the ratio of the area is 64 to 25, I'm going to set that up with 32 to x. I just have to square each of those. So when I cross multiply here, you can cross multiply and solve it. Does anyone know without cross multiplying what that would be? Xander?
12.5.
How did you get 12.5?
Because 32 is half of 64, 12.5 is half.
Okay, so you might just notice that this is dividing by 2, so I'm going to divide that one by 2. It's fine if you don't notice that. You can always cross multiply and then solve for x. What's that?
Is it like a direct formula to follow this?
I wouldn't say it's a direct formula. What you're going to do is you're going to find the ratio of the areas by squaring that ratio of the sides. So if the ratio of the sides is a over b, the ratio of the areas would be a squared over b squared. Just squaring each part of that. Okay, when I'm looking at this one here, what's the ratio of the sides? You could say 6 to 8. If you want to simplify that, you can. Especially if you want to do more of this in your head, I probably would simplify that, but you'll get the same answer even if you don't. What is the ratio of the sides if you choose to simplify it? 3 to 4. So then what's the ratio of the areas? 9 to 16. So squaring each part of that. And since I did like the small one to the large one, I'm going to put 13.5 over the area of, I'll call that x. This one's not as obvious. You can't just tell, oh, you're just doubling it or taking half of it. So you're going to set this one up and cross multiply. So 13.5 times 16. Just try this on your calculator to make sure you know where this answer is coming from. You should get 24, and that's going to be square feet. Okay, and then for these are just worded differently. Now they give you the ratio of the areas, so you need to go back and find the side length that you would start out with this. So the ratio of the areas here is 50 to 72. What I would do first all of the time is when I can simplify that. Can I simplify 50 to 72? What can I divide each of those by? 2. So that's going to be 25 to 36 is the ratio of the areas. How can I go back now for the ratio of the sides? How did you get 5 to 6? Because now, because we're going from the squared version, we're going to take the square root of each of those. So the ratio of the sides is 5 to 6. Setting that up with these sides here, x and 6. Make sure that because I put like the smaller one on top and then the bigger one, I'm going to put x over 6. You probably don't have to cross multiply here. What would this side be? 5. 5 inches would be your area. If it wasn't, you know, just the same numbers again, you could always cross multiply and solve for x and then answer the question accordingly. 5 inches would be like this side here. That would be the answer. Okay, or for the second one here, the ratio of the areas is 400 to 64. Again, if and when you can, I think it's easier to simplify it first. So 400 over 64. When you simplify that, that's the same thing as 25 to 4. And your calculator can do that if you're not quite sure what to divide by. Does everybody know how to type that into their calculator to simplify it? Okay, ask me afterwards if you need help simplifying that. This is the ratio of the areas. What's the ratio of the sides? When you take the square root of each of those, what's the ratio of the sides? 5 to 2. So the ratio of the sides is 5 to 2. I'm going to put that with the 40 and the x, so that'll be 40 over x. You can cross multiply there. You should get x to be 16, and that'll be millimeters. We have this pentagon. Would somebody, oh, actually I'll read it so then in the video it's there too. But it says the pentagon, including its center courtyard, occupies approximately 34 acres or 1,481,000 square feet of land. Each outer wall of the regular pentagon building is 921 feet in length. So use the information on the left. Orlando and Mia are making a scale model of the Pentagon. You don't want to make a scale model of the Pentagon? Oh, that's too bad. Well, this would be how you would do it. If the area of the base of their model is approximately 50 square inches, how many times the length of each outer wall is the Pentagon, is the length of the outer wall of the model?
Well, if Mia's the one doing the problem, maybe she should tell us the answer.
You got it, Mia? You got it figured out already? Okay, so we have a little problem here that these units are not the same units. Did anyone notice that? No? Okay, so we're just now noticing that. So the model is 50 square inches. And then the actual thing, it gives it to us in square feet. So we want to convert this first. We want to convert this 50 square inches to how many square feet that's going to be. Okay, and this is a time that students sometimes will make mistakes because they think, oh, well, there's 12 inches in a foot, so that means 1 square foot is the same thing as 12 square inches. Is that true? No. How many square inches is 1 square foot? How can you find that out?
144.
How'd you get 144?
12 times 12.
Yeah, because a square foot is 12 inches by 12 inches. This is why it doesn't just work to, you know, change the scale by just saying, oh, it's the same scale. You'd have to square each part of that for this here. So I'm going to take 50 divided by 144, and it'd be very helpful probably if you had your calculator. So that's .3472 square feet, so not an entire square foot, for the area of this model. So what I want to do is I want to find what the scale factor is. So the scale factor for the area is this .3472 number, that many square feet, compared to, I mean, this is a lot of square feet, 1,481,000 square feet for the actual. It's going to be hard for me to take that and like take the square root of each of those and then simplify that. So what I'm going to do is I'm just going to divide those first. We're going to end up with a decimal. We're going to end up doing a lot of this on our calculator. So have your calculator handy. Okay, we're going to take that number, that .3472, and divide that by the 1,481,000. And this is, it might be easier to write it in scientific notation, but it's .000000234. That's for the area. So how could I find the ratio of the sides? This would be like square units. I'm going to take the square root of that. So I'm just going to leave that on my calculator and do the square root of that answer. The ratio of the sides is .000484. Okay, the recommendation of the book is to take this and just round it. They're going to say that this is approximately .0005. We usually don't write ratios as decimals like this. Usually we write ratios as fractions. So what place value, this is really good review from like years and years and years ago. What place value is that 5 in? What place value would this be? This would be tenths, hundredths, thousandths, 10,000ths. So this is 5 10,000ths, which is the same thing when you divide each of those by 5 as, let me get rid of this. Okay, let me move it over there. As 1 over 2,000. So in other words, what is the ratio of one to the other? This is 1/2000th of the real thing. So for every like 1 inch, that would be 2,000 inches. For every 1, foot, it'd be 2,000 feet. For every 1 millimeter, it'd be 2,000 millimeters.